Okay, this is activity 3, quadratics. We're sketching parabolas where the parabolas of the type y equals ax squared plus c. Okay, where a is greater than 0. So concave up parabola and shifted either up or down. So sorry, I had recorded this before, but the sound didn't work, so we're just trying it again. So I'm sketching 3 parabolas here, y equals x squared plus 3, and y equals x squared minus 2. Just done a table of values for y equals x squared. We've already sketched this parabola before. So when x is negative 2, y is positive 4, because it's negative 2 times negative 2 is positive 4. When x is negative 1 times negative 1 is positive 1. When x is 0, y is 0. When x is 1, 1 squared is 1, and when x is 2, 2 squared is 4. So we can see it's symmetrical. That is the yellow parabola there. So negative 2, 4, negative 1, 1 here, 0, 0, 1, 1, and 2, 4. And so y equals x squared is the yellow. It's highlighted in yellow. Okay, so y equals x squared is highlighted in yellow. Now the next one is y equals x squared plus 3. So that's going to be in pink. So the values, we've already sketched or have a table of values for y equals x squared. They're there. And whatever y value we end up with, we just add 3. Just looking at the first one, negative 2 squared is negative 2 times negative 2 is positive 4, plus 3 is 7. Negative 1 squared is negative 1 times negative 1 is positive 1, plus 3 is 4. 0 squared is 0, plus 3 is 3. Look, the negative 1 and the 1 give the same answer because it's squared, and the 2 and the negative 2 give the same answer. So if you just compare these two table of values, you can see that 3 has been added onto each y value at each particular x value. So basically y equals x squared plus 3 is the y equals x squared curve shifted up 3 units. So instead of 0, 0, it's now 0, 3. Instead of 1, 1, it's now 1, 4. Instead of negative 1, 1, we've got negative 1, 4, and so on. So that's been shifted up 3 units. And the curve y equals x squared minus 2, just looking at the y equals x squared plus 3, that will be the y equals x squared curve shifted down 2 units because of the minus 2. Okay, so if we're just looking at our table of values, negative 2 squared is 4, 4 minus 2 is 2. Negative 1 squared is 1, 1 minus 2 is negative 1. Um, 0 squared is 0, take away 2 is negative 2. 1 squared is 1, take away 2 is negative 1, and 2 squared is 4. 4 take away 2 is positive 2. So we can see that this is this curve. We've got negative 2, 2. We've got negative 1, negative 1. 0, negative 2. 1, negative 1, and 2, 2. So just highlighting that curve. Sorry, that one didn't print very well on your sheet. Okay, let's put some. Okay, so basically we can see what's happened to the y equals x squared curve. X squared plus 3 shifted up 3 units. X squared minus 2 shifted down 2 units. And also you can see when you substitute x is 0, you get the y-intercept of negative 2 for the x squared minus 2. When x is 0 on the yellow curve, for y equals x squared, when x is 0, y is 0, and for the pink highlighted curve, when x is 0, y is 3, and that cuts at 3 as well. So they are parabolas of the type y equals ax squared plus c, so y equals ax squared plus c, where a is greater than 0, so it's concave up, and where if it's plus c, if the c is positive, it moves up, and if c is negative, it moves down. Okay, and now for activity 4. And these are parabolas of the type, again, y equals ax squared plus c, but this is where a is less than 0. So these parabolas are concave down. But they're concave down, but then shifted up or down. Now, these have already been coloured, okay? So the first parabola, okay, let's have a look. They are all of the negative x squared type. Sorry, I didn't write which ones they were. So the first one, the red one, is y equals negative x squared, and it's shifted up 3 units plus 3. So let's just do a quick table of values just to confirm that. I'm just going to do it 3 values, so -1, 0, and +1. So when x is -1, so we've got, be careful here, because it's y equals negative. So I've got my negative there, but then I have to substitute my -1. So -1 squared plus 3. So I get negative. Now -1 squared is +1, so it's -1 plus 3, which is +2. Okay, so you've got to be careful there. When x is 0, we get -0 squared. Well, that's just 0 plus 3 is 3. And when x is 1, be careful here, I've got negative, and then x is 1, so I just do 1 squared plus 3. Now the negative is not squared, just the 1 is squared, so it's negative. 1 squared is 1 plus 3, which is +2. So remembering that these curves are symmetrical, so whatever value you get for -1, you'll get the same value for +1. So just seeing that this is this curve, so when x is -1, y is 2. When x is 0, y is 3, and when x is 1, y is 2. So therefore the red curve is y equals -x squared plus 3. Now the blue curve, so they are all actually y equals -x squared curves shifted. The blue curve will be y equals -x squared, and we can see -x squared. You might want to draw that one in too. So when x is 0, y is 0. When x is 1, y is 1. When x is -1, y is 1. So, and when x is -2, y is 4. Just got to be careful here. But I'm actually going to do that in yellow. So this is the curve y equals -x squared highlighted in yellow. Okay, I just didn't get to draw that. So when x is 1, y is 1, and 2 squared, sorry, -2 squared, sorry, is -4. So I've just put in the curve y equals -x squared as well. Okay, just doing a quick table of values for that. When x is -1, be careful because it's negative. Now, -1 squared is 1, so it's -1. 0 squared is 0, so -0 is just 0. And when x is 1, I've got 1 squared is 1, and I'll put a negative in front of it, and I'll just do 2 as well. 2 squared is 4, and we get -4. The negative is not squared, just the x value is squared. So the yellow curve is y equals -x squared. And we can see that this blue curve down here, therefore, blue curve, is y equals -x squared, just shifted up 1 unit, plus 1. And the green curve here is the negative, because these are all concave down, so they're all -x squared. The green curve is y equals -x squared, and it's shifted down 2 units, -2. Okay? So that's just those. So you can shift the concave up parabola up or down, and you can also shift the concave down parabola up or down. Therefore, to graph parabolas of the type y equals ax squared plus c, you will determine the shape of the parabola by examining the size and the sign of a. So if a is positive, if a is greater than 0, the curve looks like this, and if a is less than 0, so this one's concave up, and the curve will be concave down. If a is less than 0, remembering the bigger the size of a, so if a is, say, for example, 5x squared is steeper than, say, 2x squared. So that's what they mean by the size and the sign, all right? You can complete a table of values as well, and always in the table of values for all our parabolas, the vertex will be on this y-axis, okay? Now, for example, if we want to match each quadratic function with the graph below, I want you to pause the video and try it on your own. But you can see we've got 6 graphs, right, and 6 equations. And the first thing you want to be doing, maybe let's look at the 2 downwards, the 2 concave downs. So the 2 concave down ones are A and F, okay? So let's look at the formulas for the concave down ones. And we've got C, y equals negative 7x squared, and B, y equals negative x squared plus 1. So this one has obviously been shifted up 1 unit, and this one here should be narrower or steeper. So they're both concave down, but this one is much narrower here, and this one will sit at, the vertex will be at the origin, like this, okay? And notice this is a lot narrower than that. So this graph here should be y equals negative x squared, all right? And this graph here should be, from the list, y equals negative x squared plus 1. Okay, I know that no other values have been put on the graph, but just looking at the shape and comparing the width of those two, they're both concave down. This one has a bigger a, value of a in front, so the 7 makes it steeper than the 1 that would be in front here, and this graph has been shifted up. So now we've got, well, we can see graph D, that's just concave up and it's not shifted up or down, whereas this one's shifted up and it's wider. This has been shifted down, and this one's been shifted down, looks like a lot more than this one, and this does look steeper than this one. So why don't you try D next? That would be a good one to do, because it hasn't been shifted up or down. So concave up, this looks like it's shifted down. This looks like it's shifted up and it's wider because it's half x squared. This is shifted down, and this hasn't been shifted up or down. So it's just y equals 2x squared. It's a little bit steeper, but it hasn't been shifted up or down. So this graph here should be y equals 2x squared. Now, of the 3 remaining, this is the only one that's been shifted up from, so normally the vertex sits at the origin. This one has definitely been shifted up, and it's quite wide, so it's not steep like these others. So this one would be E. Y equals a half x squared plus 1. Now you just have to choose between C and E. Looks like E is shifted down more, sorry, C, and it's narrower as well. So we'll have a bigger value of A. So let's look. So 2x squared minus 2, that's steeper and shifted down more. And this is just x squared minus 1. It's just sort of your normal regular width and just shifted down 1. So E should be y equals x squared minus 1. And C should be y equals 2x squared minus 2. Okay, it's narrower and it's shifted down more compared to this one. Okay. Okay, now for question 3. Now these are very typical of the types of questions you'll get in the next exercise, okay? So a ball is thrown up in the air from the balcony of Ryan's apartment, and its height above ground level after t seconds is given by the quadratic function h equals negative 5t squared plus 20t plus 25, where h is the height in meters. Now, I know that we've told you that all quadratic functions, you know that quadratic functions have highest power of 2, so it'll be like x squared or t squared. However, and you know about the constants, but you can have a regular just x term as well. So for example, a quadratic equation could look like this, like y equals negative 5, say x squared plus 20x plus 25. That's a quadratic function as well, because the highest power of x is a 2, so it's an x squared. We can tell it's concave down. I know that you're not used to seeing this 20x, but when you see this middle term, if it's just the negative 5x squared plus 25, it means that it's only shifted up or down. But when you have this plus 20x, see, parabolas don't have to be just shifted up or down. They can also be shifted sideways. They can actually be shifted up, down, like either up and sideways or down and sideways to the left or the right. So I could have parabolas here, I could have parabolas upwards there or here, or I could have a parabola drawn there. So when the parabola, you just have to recognize parabolas of the simplest type where they're shifted up or down. But in the application type questions, to be able to draw this parabola, you just do it by substituting, okay? Now, h is in place of y and t is in place of x, and we know that the value of y depends on what we substitute for x. So with this question, what is the independent variable? So the value of h depends on t, so the independent variable is t, which is time. Okay, so in other words, a ball is thrown up it's thrown up in the air from the balcony of Ryan's apartment, and its height above level after t seconds. So it depends on what the time is, what height the ball will be at. So the height depends on the time after you have thrown the ball, okay, and the height is in meters. Now they're saying to graph h equals -5t squared plus 20t for values of t from 0 to 6. I'm just going to do a table of values here. So we've got, normally it's, like I said, x and y. We're using t and h. So we've got 0, 1, 2, 3, 4, 5, can barely fit this, and 6. Now, like I said, this parabola has been shifted sideways. So let's look at when t is 0. So 0 squared is 0. So -5 times 0 is 0, plus 20 times 0 is 0. So this is all 0 so far. Plus 25, we get 25. Now with the others, you can just enter it on your calculator. When t is 1, for example, -5 times, now 1 squared is 1. So it's -5 times 1, which is -5. Plus, now 20 times 1 is 20, so -5 plus 20 plus 25 gives us a value of 40. Now when t is 2, so we've got 2 squared is, so you can just put it on your calculator, you can just go -5 bracket like this, and you can go 2 squared, close bracket, right, plus 20 times 2, or 20 bracket 2, it doesn't matter, plus 25. So you're just substituting t is 2 into this formula, and we get 45 here. And then when t is 3, I'm just going to substitute that in. -5 times 3 squared plus 20 times 3 plus 25 gives me a value of 40. Now we can see that, remember, when you throw a ball, it's going to reach some peak and it's going to come back down. Now because this was thrown up from a balcony, this was not thrown from the ground, pretend this is the building, it's actually going to hit the ground further down here. So the ball will eventually reach a height and then it'll come back down. It looks like this height that it's reached is 45. We know that that's the maximum because we've got a 40 and a 40 on each side evenly away from the 2. So we're counting up by 1, 0, 1, 2, 3, 4, 5, 6. For this to be symmetrical, when I substitute t is 4, I should get 25 as well. Because notice it's 25, 40, 45. I've reached my peak down to 40. This should be 25 when I substitute t equals 4 into this equation. So I'm going to do that now. So -5 times 4 squared plus 20 times 4 plus 25 gives me a value of 25. And now substituting in t is 5. So we've got -5 times 5 squared plus 20 times 5 plus 25 gives me a height of 0. Now, when I put t is 6, I've got -5 times 6 squared plus 20 times 6 plus 25, and I get -35. Now, this is a bit strange because I'm throwing a ball up into the air, and the height is the height in meters above the ground. And when I get time is 6, I get -35 for the height, which is impossible. You can't go below the ground. Okay, so I'm just going to graph here. Now, what I'll do, remember this is like, this is like my x-axis, my y-axis. My y-axis has a maximum of 45 and a minimum of 35. I'm going to see what I can fit here. So if I've got, let's say 50 up here, then I've got 40, 30, 40, 30, 20, 10, 0, -10, -20, -30, 50. I'm going to actually try and change the scale. I might go 45, 40, 35, 30, 25, 20, 15, 10, 5, 0. I know I'm not going to get negative 35, okay? I know that's not going to happen. And negative 10, negative 5, negative 10, negative 15, so on. Negative 35 is going to be down here somewhere, but I'm not going to worry about it, okay? So I'm going to put my horizontal axis here. It's going to go and get a ruler. And here I've got the height. So when time is 0, height is 25 up here. Okay, I think I'll go 1, 2. I'm going to try and space this out. I'm actually going to move this across here. I'm not going to fit my last value on in anyway. So I've got time 1, time 2, time 3, time 4, time 5. 6 would be here somewhere. Remember, I can't even fit that value down here anyway. So when time is 0, height is 25. When time is 1, height is 40. When time is 2 seconds, height is 45. When time is 3 seconds, height is 40. When the time is 4 seconds, height is 25. Now we're back to, so this is completely symmetrical here. Remember, we didn't start, when t is 0, this was thrown from a balcony, which is why it doesn't start from ground down here. When time is 5, we got height is 0, which is down here. And when time is 6, we got height is negative 35, which, you know, is going to be down here somewhere. What I'm going to do, I'm going to start sketching. I'm going to start drawing this curve. Got to draw a nice smooth curve when you plot these points because it's a parabola. You don't draw straight lines between the points, so you just draw a smooth curve. Now, let's continue that path. And negative 35, I'll just do a quick measure down here. 35 should be 7 centimeters, so I've got to go 7 centimeters down here. That's where my negative 35 is. Okay, and I'll do, this is 2 centimeters across from 5, that's at 6. I'll just do 7 centimeters down here. It's here. There we go. So I was a little bit off. So it goes like this. That is the point down there. I think that is 6. Yep, 6 negative 35. Now, in context, this can't happen because the ball can't go below the ground unless there's a big hole in the ground. Okay, so let's look back. So we've graphed the function. Okay, so we've graphed it. All right, you don't have to. Obviously, the ball hits the ground after 5 seconds. Okay. Now, what is the vertical intercept of the graph and what does it represent? So the vertical intercept. So the vertical intercept equals 25, and it's the height at which, or from which, height from which the ball was thrown. It's basically the height of the balcony, okay? Now, question D, what is the maximum height of the ball? And we can see the maximum height of the ball. So the maximum height of the ball equals 45 meters at time 2 seconds. Now, notice that you can only see part of the parabola here. Because I've got like 4, 25 and 0, 25, if I actually did start this, we can't have negative time as well, but this here would hit at time -1 because I've got 1 more second to hit the ground from a height of 25. So if this were to continue, it would hit at -1, but this does not exist because the ball is thrown. This is the starting point here, not here, okay? So it still is a symmetrical parabola, but it's only part of the parabola, okay? We only start from here because the ball was thrown from a balcony of height 25 meters. So the maximum height, as we said, was 45 meters. It occurs at time 2 seconds. And when does the ball hit the ground? So we can see that the ball hits the ground after 5 seconds. Because this is when h equals 0, the height. Okay, because the height is the height of the ball in meters. Okay, so we'll be doing more of these in the next exercise.